Thinking Aloud. Conversations on the leading edge of knowledge and discovery with parapsychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. Today, we're going to explore time, consciousness, and hyperspace. My guest is Professor Bernard Carr, who is Professor of Mathematics and Astronomy at Queen Mary, University of London. He received his doctorate in Trinity College, Cambridge, England, working under the supervision of Stephen Hawking, with whom he actually lived in the Hawking household in the early years of their relationship back in the 1970s. He is co-author of the book Quantum Black Holes, and he is editor of the anthology Universe or Multiverse. He is also the recipient of the Adams Prize in Mathematics. He is a former president of the Society for Psychical Research in England, and he currently serves as president of the Scientific and Medical Network, an organization largely based in Europe dedicated to exploring human consciousness. This is an internet interview, and now I'll switch over to the internet video. Welcome, Bernard. It's a pleasure to be with you once again.
Thank you, Jeff. It's a pleasure to be here again.
Today, we're going to explore what I think is one of your favorite topics, the nature of hyperspace, how it relates to cosmology, physics, the nature of time, and particularly consciousness. And I think as a physicist, the nature of time and space become very important, don't they?
Time in particular is absolutely crucial to trying to understand consciousness and psi. Furthermore, it provides the link with mainstream physics, because physics may be reluctant to talk about consciousness, and it's certainly reluctant to talk about psi. However, physics does talk about time, and of course it talks about space, because space and time are the arena of all physical phenomena. And yet, time is also very important for our experience of the world, and therefore there is a natural link between physics and consciousness via time. And although time does play a crucial role in physics, it isn't well understood. There are aspects of time which we do not understand from a physical perspective, and I expect we'll come on to that later. But to me, the problem of time, even within physics, will not be properly solved until one has an understanding of consciousness. Because the key feature of consciousness is it does involve the passage of time. And the passage of time is a great mystery within physics, because within the standard formalism of relativity, there is no passage of time. Because in Einstein's theory of relativity, past, present, and future coexist in the block universe. And there is no possible description of the flow of time. And yet that is what we experience. So the question is, how do you resolve the problem of the flow of time? And how do you fit that into modern physics? And I'm going to later on give my own perspective on that problem.
I mean, there are people who say from an experiential point of view, all we ever really experience is the now moment. We never actually experience the past or the future.
That is true, but the point is the now moment, ironically, which is the only thing that exists in our experience, does not exist within the standard description of physics. Because in the standard description of physics, past, present, and future coexist. And as Einstein said, that the existence of the now is a stubbornly persistent illusion. So the question is, how do we explain that illusion, and how do we relate it to physics?
Didn't Einstein also suggest that both time and space are sort of secondary to matter and energy?
What he said was that in some sense, because in his general theory of relativity, space-time is curved, and the nature of space-time is therefore determined by the matter, because it's the matter which is actually deforming the space-time through its gravitational field. So there is an intimate link in Einstein's theory between matter and the nature of space-time. And of course, Einstein's theory of general relativity tells us what that link is. But in some sense, both matter and energy and space and time are fundamental in the relativistic description of the world.
With regard to curved space, that has always seemed to me to be counterintuitive. You know, we grow up with a kind of Euclidean notion of space. And so we now, because of Einstein, I guess we accept that space can be curved, that there are other geometric models besides Euclidean geometry. And I presume the same is probably true of time as well.
The point is that in our experience of the world, it does seem that space is what you say Euclidean. That's to say it isn't curved. But that's because we're only looking at a very local region. But in Einstein's theory of general relativity, space does become curved if you look on a large enough scale. For example, if the universe was closed, if you walked in a straight line long enough, you come back to your starting point, because the space itself is curved in some models. And of course, also if you're near a black hole, space and time becomes very, very distorted. So both spatial and temporal measurements get changed considerably. It's counterintuitive because the simple mathematics we do in school does assume that space is Euclidean, that in other words, that it isn't curved. It obeys Pythagoras' equations, if you like. But that's because that is a feature of the world if you look on small scales or when there are weak gravitational fields. But when the gravitational field becomes strong, the curvature becomes more noticeable. But the idea of having curved space had a respectable history long before Einstein came along. I mean, in the 18th and 19th centuries, there were mathematicians like Riemann and Gauss and people who studied the properties of curved spaces before it was realized that they might actually have applications in the real world. So it's always been a mathematically respectable idea, but it was only with the advent of Einstein's theory of general relativity did it become physically acceptable and indeed inevitable.
With regard to hyperspace, we're talking about more than 3 dimensions of space. When did that enter into physics?
In the Newtonian day, the idea was that the arena of physics was 3-dimensional space. And this was absolute space. Everyone agreed that this was space. They'd all agree with their measurements of rulers and things like that. Time was also absolute. It was assumed to flow at the same rate for everybody. And so this was sort of God's own time, if you like. And that was the view that prevailed for several hundred years. But then when Einstein came along, he realized that actually space and time are not absolute. They depend on the observer. They depend on how the observer is moving. And in particular, the only way to have a consistent account of the laws of physics, in particular, the Maxwell's equations for electromagnetism, for example, is to assume that space and time are merged as part of 4-dimensional space-time. And that means that space and time measurements depend upon how you move. That's in special relativity. So that, you know, clocks run slowly. If you're moving fast, clocks run slowly. And rulers shrink. When Einstein's general theory came along, he found that the distortions were even more dramatic. Being in a gravitational field would slow down clocks and distort rulers' measurements as well. So that's why, with the Einstein's theory, the old Newtonian picture of an absolute space and time broke down, and then you had the real space, if you like, was the 4-dimensional space-time, sometimes called Minkowski space. But at this point, we were still dealing with a 4-dimensional universe. Now, the introduction of these other dimensions then followed about a few decades later. And I can just briefly summarize how that came about. This is within physics, I should say. The concept of dimensions arose in other, in mathematics and in philosophy and esoteric literature well before, but I'm now just talking about physics. So in the 1920s, two physicists called Kaluza and Klein suggested, well, maybe there's a fifth dimension whose existence would naturally explain the existence of electromagnetism. It would unify the gravitational field, which is described by Einstein's Kerr space, with the electromagnetic field by incorporating this fifth dimension. Now, you can't see this fifth dimension because it had to be wrapped up very small on what's called the Planck length, 10 to the minus 33 centimeters. But nevertheless, invoking this extra dimension was beautifully unified the equations of gravity and electromagnetism. But then people rather lost interest in this model because they got swept away by quantum theory and things like that. But then the model was revived in the 1980s when superstring theory came along, and it was realized that you could unify all the other forces as well, not just electricity and gravitation, but the weak and the strong forces, if you invoked extra dimensions. And in the first theories of superstring model, you had 6 extra dimensions, so that you would have 10 dimensions in total. The 4 macroscopic dimensions, the 3 of space and the 1 of time, and the 6 internal dimensions, which were wrapped up very small. Now, the problem is that there were quite a number of different versions of superstring theory, but then in the mid-1990s, Ed Witten realized that you could actually amalgamate all these theories into what's called M-theory if you invoke another dimension, an 11th dimension. So then the favored picture was that you have, if you like, 4 macroscopic dimensions and 7 extra dimensions. And so that was the, if you like, the standard model of M-theory, which hundreds of physicists have been working on very hard for the last 20 years. But the fact is, we still don't have definite confirmation of these extra dimensions. People have been looking for these extra dimensions in the Large Hadron Collider, for example, in Geneva, and there isn't yet any evidence for them. On the other hand, that doesn't mean they're not there. It just means we haven't reached the energy to which you can find them, because in fact, in some sense, the smaller the dimension, the higher the energy required. But it might in principle be possible that we would have found evidence for them.
And the idea is that all of these extra dimensions are at the Planck scale. They're so tiny that anything within the dimension, I suppose, would have to be what you would call subquantum.
Well, I wouldn't say subquantum. This is all in the quantum domain. There's a distinction between quantum gravity and quantum theory. Quantum gravity effects come in when you go below the Planck scale. You're in the quantum domain on much, much larger scales than that. The point is that when you get to this 10 to the minus 33 centimeters, that is when we know quantum gravity effects come in. Now, it isn't clear that all these extra dimensions are wrapped up on that scale. That was the simplest picture. In the original Kaluza-Klein picture, they were wrapped up on the Planck scale. In the simplest superstring theory, they're wrapped up on the Planck scale, but it doesn't have to be like that. And in some versions of M-theory, you can have one of the dimensions being extended and not being wrapped up. And for example, in a previous interview, I referred to the brain picture, which says that the physical world is a 4-dimensional brain, B-R-A-N-E, in a 5-dimensional space, which is called the bulk. Now, the 5th dimension is associated with one of these extra dimensions. But the assumption there is, though, that the remaining dimensions, they're still wrapped up on a small scale. But you can have other theories in which, in fact, all the extra dimensions may be bigger than the Planck scale. You could have these extra dimensions which have a hierarchy of scales going all the way from the macroscopic scale all the way down to the Planck scale. I mean, it's even possible that the macroscopic scales associated with ordinary 3-dimensional space are closed. I mean, I mentioned the possibility that if the universe is closed, if you walk on in a straight line, eventually you come back to your starting point. That applies if the spatial dimensions are also curved also closed up. So in principle, it's possible that all the dimensions, even the macroscopic and the microscopic ones, are closed, just on vastly different scales. If the macroscopic dimensions of space are closed, it's going to be on a scale of 10 to the 20 light years or something like that. So we wouldn't notice it. So the simplest model says all these dimensions have the Planck scale, which is 10 to the minus 33 centimeters. But there are other more complicated models where they can have a range of possible scales.
In the history of philosophy, there's also been a dispute, I guess you could say, about the difference between space as we perceive it, perceptual space, versus physical space.
Indeed. And I mean, really, the history of this subject goes back a long, long way. I'm not sure how much detail you want me to go into. I mean, I think I'm going to go all the way back to Plato. You know, when Plato talked about the famous Plato's cave, where the analogy is the people in the cave are only seeing the shadows of the real objects, and they mistake the shadows for the real objects. And the idea there is that in some sense, the reality we perceive is only a reflection of a higher reality. And in some sense, Plato's cave is using the analog of a higher dimension, though he doesn't express it in those terms. On the other hand, his contemporary Aristotle thought this was nonsense. He didn't like that idea. Plato was much more into beautiful mathematical ideas, rather like, M-theory. And then if you go to the 17th century, for example, I think it was the philosopher Henry Moore, he postulated that spirits came from an extra dimension. Presumably that would mean a fourth dimension. This was before Einstein came along, so we only had 3 dimensions at that time. On the other hand, his contemporary John Wallis thought this idea was monstrous, so it was regarded as very controversial. After that, of course, the mathematicians came along and formulated the idea of higher dimensions in a respectable mathematical way. We've already referred to that. And then I suppose when you get into the middle of the 19th century, then there was a great interest in these higher dimensional spaces, I suppose you might say from an occult perspective. So this is well before physics, but this is between the mathematical age, if you like, and the physical age of higher dimensions. It was the occult age. And this started with, there was the famous book by Abbott called Flatland, and I'm sure you know this novel, and the idea of Flatland was that he imagined that these people lived in a 2-dimensional space. And then he imagined what would happen if there was an encounter from a being from the 3rd dimension. And he realized that if there was a being from the 3rd dimension interacting with the 2-dimensional space, it would produce all sorts of strange effects. For example, you might have a 2-dimensional bottle of wine, and then the wine disappears as someone from the 3rd dimension sucks up the wine. You might have an object which disappears from one place, goes into the extra dimension, and then reappears somewhere else. You might have the idea that a person goes up into the extra dimension, does a flip, and then comes back and his heart's gone on the other side of his body. Or you might have the idea that lots of individual things, objects which are disconnected in 2-dimensional space might be connected in the 3-dimensional space. Now, this was a metaphor, though, because the idea was that if this is happening in a 2-dimensional space with a 3rd dimension, maybe the same would be true if you had a 3-dimensional space with an intervention from the 4th dimension, a 4th spatial dimension. And of course, in that light, what Abbott was saying was very reminiscent of the spiritualistic phenomena, where you would have objects moving about, objects disappearing and reappearing, and a multitude of mysterious phenomena. So this book this novel, I should say, was very influential. I mean, it was a beautiful novel because it was also a sort of parody on the social conventions of the time. But it was mainly conveying this idea that maybe interventions from an extra dimension could be responsible for psychic or even spiritualistic phenomena. And about the same time, there was an astronomer who also suggested that there could be a fourth dimension, and that this could explain spiritualistic phenomena. Zollner. Actually, I think he even lost his job because he proposed this idea. Because, I mean, he was a respectable astronomer, but when Zollner suggested that this extra dimension could explain psychic or spiritualistic phenomena, he became very unpopular, and I think he lost his job as an astronomer. After that, of course, we had Hilton, who popularized the idea of the fourth dimension, and he actually he was very good at visualizing the fourth dimension, and he would lead sessions where people would learn to visualize and think in four dimensions, but he also thought of ghosts as being in the fourth dimension. So this was a period in which a lot of people were thinking of extra dimensions as being a way of explaining, if you like, ghostly phenomena. And then even at the turn of the 20th century, you had people like Ouspensky, who were also associating higher dimensions, with mystical states. But then, of course, when Einstein came along in 1905, it changed everything, because Einstein showed there was a fourth dimension, but that it wasn't space, it was time. And so, in a sense, that put an end to those speculations, because the fourth dimension existed, but it didn't exist to do what those occult people had been interested in it doing. But of course, then people started thinking, well, maybe there's a fifth dimension, which, in other words, a fourth spatial dimension, as opposed to a fourth time dimension, and maybe some of these phenomena can be explained by an intrusion from the fifth dimension. And so then people got interested in five-dimensional models. So then, of course, there was another gap, and then later on, the physicists started getting interested in the subject as well. I mean, in particular, some of the people who were interested in parapsychology, some of the paraphysicists, the paraphysicists being the subset of physicists who believed in and were interested in parapsychology, they started exploring the possibility that you could have extra dimensions. These weren't extra dimensions in the sense that Kaluza and Klein had been invoking them, but these were just, they would, for example, add extra dimensions to space and time, which in some sense was respectable even within conventional relativity, because even in conventional relativity, people, for example, have been complexifying the space and the time coordinates. And so that, in that sense, that was respectable, but those people, of course, weren't trying to explain any psychic phenomena. But the people who were trying to explain psychic phenomena, there were people like Elizabeth Rauscher and
Russell Targ.
They were sort of coming from a physics background, and they were invoking models with extra dimensions of space and time, and hypothesizing that could explain phenomena like precognition and clairvoyance and telepathy. Because if you've got higher dimensions, in some sense, you've got connections in some higher dimension. So they were physicists. And then today, of course, you have people, I mean, now we're moving into the 60s and the 70s, and you have people like Saul-Paul Sirag, who's probably got the most sophisticated model, which relates like a hierarchy of states of consciousness with a hierarchy of mathematical spaces. And then you have people like Jim Beitler, who's got a five-dimensional model. And you have other people. More recently, you've got people like Vernon Neppe and Close, his colleague Close, and they're from both higher dimensional models. So now there are quite a lot of higher dimensional models, which in some sense come from physics, but this isn't coming from mainstream physics. This is coming from the people in paraphysics, who may still be perfectly respectable physicists, but they're not the people pursuing string theory. So you've got two parallel streams here. You've got the sort of higher dimensions as studied by people in, if you like, respectable physics, which means M-theory, and you've got higher dimensions, which is pursued by people who are physicists, but nevertheless using these higher dimensions for rather unorthodox purposes.
As I recall, you had Wolfgang Pauli also exploring this question in his dream experiences and his Jungian therapy.
It's famous because of his interactions with Jung, where, of course, he was a physicist who was interested in psychic matters, or matters of the psyche, perhaps I should say. I mean, this really, Jeff, links to the question you started with, actually, which I didn't answer. And that was the relationship between these physical higher dimensions and perception. You remember you originally asked me, what is the relation between mental space and physical space? And that's really crucial, because, I mean, philosophers for a long time realized that there was a distinction between physical space and phenomenal space. I mean, phenomenal space is our perception of the world. So you've got the outside world in which the objects reside and the bodies reside. And then the idea is that we, with our brains and our sensory systems, we have an internal representation of that outside world, which is our phenomenal space. And of course, the standard view is that phenomenal space is just something created by the brain. So each of us has got our own phenomenal space, and they're all disjoint. But philosophers for a long time, I mean, certainly going back to Bertrand Russell and people like that, were interested in what is the relationship between phenomenal space, the perceived space, and physical space. And of course, that was a very vexed issue. And philosophers, you know, there was a great division between naive realism, which says the object you experience actually is the object, and representation theory, which says the object you see is only a representation of an outside object. Well, nowadays, almost everybody accepts that, of course, what you experience is a representation, because, you know, the light signal goes through the eye and it gets processed. And we know, in some sense, representation theory is right. But the question is, does that mean the naive realism is completely wrong? And it all comes down to what is the relationship between phenomenal space, and which is perceptual space, and physical space. Now, philosophers like C.D. Broad said that actually perceptual space, phenomenal space, itself has a reality. It is a genuine space on a par with physical space. And indeed, another philosopher also suggested that dream space, for example, which we all experience, was a space in its own right.
That would be Price.
This was H.H. Price, indeed. So H.H. Price said dream space is there, and we experience it every night. And just because we don't experience it when we wake up doesn't mean dream space is there. It's rather like the stars. You know, the stars, you only see them at night, but they're all the time. They're there all the time. You just don't see them. And so the idea is that there are two parallel worlds. There's the dream space and there's the waking physical space. And these, in some sense, run side by side. And Broad said, well, maybe these two spaces, maybe mental space and physical space, aren't separated. Maybe they're just part of a combined space, which a combined physical perceptual space, which in some sense consists of both physical space and perceptual space. So maybe dream space and waking space are in some sense unified. So that was C.D. Broad, who was, of course, a colleague of mine at Trinity. I mean, we only overlapped for a short time, but we were both at Trinity.
I believe he was also, like you, a former president of the Society for Psychical Research, wasn't he?
Oh, he was indeed a former president of the SBR, and quite a bit before me, of course. But the person who took the next step, I would say, was a friend of mine called John Smithers. And you may have heard of John Smithers. He was also fascinated in the link between perceptual space and physical space. I mean, I sometimes say phenomenal space, but I mean by that the same as perceptual space. And he also took the view that, in some sense, every perceptual space is a space in its own right, and that the perceptual space and the phenomenal space are also merged as you know, they're separate slices of a higher dimensional, five-dimensional space. So he's sort of taking forward the idea that Broad had. And I think it was in 1956 he wrote his first book on the subject, which was called Analysis of Perception. And really, for the next 50 years, he spent his life on this. And his last book on the topic was called The Walls of Plato's Cave, rather appropriately, bearing in mind the first topic of our conversation. And I was he was a friend of mine. I mean, I was in correspondence with him for about 20 years before I finally met him. But when I finally met him, we became good friends. Sadly, he only died about a year ago. He reached a good age. He reached the age of about, I think, 96. But he was active right until the end and still pushing these higher dimensional models. And now he was not a physicist. He was I guess a psychiatrist. But nevertheless, he was well read in physics. And my own model, which I haven't really talked about yet, my own model was, I suppose, very much a development of those sorts of ideas. So to summarize, because the picture is a little bit complicated, to summarize, there have been different approaches to higher dimensions. There's the approach which has come from the occult, which sort of faded out after the beginning of the 20th century. There's the approach which comes from mainstream physics from the beginning of the 20th century. There's the approach which comes from more modern physics, and the approach which comes from paraphysics, which is explicitly trying to link these phenomena with consciousness. And then there is the approach which comes from the philosophers of mind, which is the approach advocated by people like Smithers and Broad. So my view is that in some sense you have to see all of these views as part of a whole.
Wouldn't you also want to add approaches from mathematics? Like I understand David Hilbert, the great mathematician, talks about Hilbert's space, which is, I think, infinitely many dimensions.
Oh, absolutely. I mean, I could have added mathematics. I was including mathematics. I mean, I mentioned mathematics earlier on. I was sort of including that as, in some sense, part of physics, because you could argue that these modern higher dimensional theories of physics are no more than mathematics. Some physicist skeptics say it's mathematics rather than physics because we haven't yet detected these extra dimensions. So I'm really, when I say physics, I'm saying physics stroke mathematics, because the two things go together. But you're right that the concept arose in mathematics 100, if not 200 years before it arose within mainstream physics. But that's the whole question of the link between mathematics and physics, and the way in which they marry together, which is itself a profound question. So that I've given a sort of overview of the different approaches to higher dimensions, and as I say, I start from that standpoint, and then I have my own picture which I can describe in a little bit more detail. But before saying that, Jeff, I think I should step back a bit and say why I think it really is important to link physics with these phenomena, and that why I should also be stressing that although I'm advocating higher dimensions, this isn't the only approach you could take as a physicist. So can I take a little detour for 5 minutes to discuss that point?
Of course.
Right. I mean, first of all, as you know, I am a physicist, and so I am very keen to expand physics as far as possible. But why is it so important to link the psi with physics? And I would always say, well, first of all, it's good for psi. I mean, science will not appreciate psychical research as a respectable field until it's based on a theory. We have a lot of data now, I would say overwhelming evidence for some psychic phenomena, so-called psychic phenomena, but there is no uniformly agreed theory. Until we have a theory, it will not be part of mainstream science, because the whole basis of science is you have a sort of combination of experiment, observation, data, and theory. And we so far lack a theory. I mean, there are plenty of suggested theories, but there's no uniformly agreed theory. So we need a theory of psi. Of course, you can have a psi on different levels, a theory of psi on many different levels. You can have a psychological theory, or you might have a biological theory. But I'm saying you need a physical theory, because in some sense, physics, in a sort of reductionist picture, physics underlies all the sciences. So I'm not a reductionist, but nevertheless, I do think that a physical theory of psi will be the most fundamental. So you need a theory, an extension of physics, to make psi respectable. But it would also be good for physics, because physics thrives on having little things it doesn't understand. And I think I mentioned in my last interview that was why the early researchers in psychical research often were physicists. They thought it was going to give hints of some new physical force. And I still think that if you really do have an extension of physics, it's going to be good for physics, because we're going to have discovered something new about physics. It may relate to the higher dimensions, it may not, but we will have discovered something about physics. And as I've said before, if these phenomena are real, they do involve an extension with physics. I suppose the third reason is that people sometimes say, well, physics is already weird enough to accommodate psychic phenomena. Now, you have to be a little bit careful of that approach, because there is a temptation to say if one thing's weird and another thing's weird, you link them up. And it's true, physics does allow weird phenomena. It's got, you might have wormholes and time machines and all sorts of quantum effects. And I think it was Arthur Koestler who said first, these phenomena are sufficiently weird that they could allow psychic phenomena. But I don't think that's a very strong argument, and it's certainly an argument which mainstream physicists get annoyed with. You can't say just because something weird is weird, it must explain psychic phenomena. Nevertheless, at some point, if you believe physics is going to be expanded to accommodate these phenomena, it will have done that. So at some point, it will turn out some phenomena really are weird enough to explain psi, but one can't say the weirdness alone is the explanation. So granted, therefore, that we need some link with physics, what sort of physical approach could you adopt? And there are several. I mean, I suppose the earliest approach was to say, well, it's some form of transmission of some signal. Remember, they just discovered radio waves, when at the birth of the SBR, and in the beginning of the 20th century. So people said, well, maybe telepathy just involves some transmission of some other signal. I mean, maybe radio waves, that wouldn't work, but maybe some other particle we don't know about, or some field which links between the brain. In other words, implying it's got some very natural physical explanation, even though it might be using some physical particle or field we don't yet know about. I've never liked that model, simply because, first of all, we don't know what the receptor is in the brain which can receive these signals, and we don't know how we can encode the information in these signals. But nevertheless, historically, there's been an interest in that. But sometimes people say, well, this also isn't very valid because there doesn't seem to be any fall off with distance with ESP, for example, and therefore people say it can't be a normal physical force. Well, that's not very convincing either, because not everything falls off with distance. But there is a general feeling, I think, that psi involves what is sometimes described as non-local effects, implying that you aren't going to have a normal type of physical force. So that was the first explanation. A different sort of explanation was to say, well, maybe the body has some sort of field some biophysical field which is connected with these phenomena, and maybe that's what's explaining some of these phenomena. The interaction between the biophysical fields can explain ESP or miraculous healing or things like that. Well, that may be okay in principle, but the trouble is that we don't have any direct evidence for these other fields, which are meant to be. I mean, they could be there, but if you can't detect them, or if you haven't succeeded in detecting them with a physical instrument, it's not quite clear whether they actually qualify. But I don't want to be too derogatory about these ideas, because I know there are a lot of people who do pursue them. But I have to say, from my personal perspective, it's not a sufficient explanation. Of course, the third type of explanation is to do with quantum theory. And because there are all sorts of features of quantum theory which might relate to psychic phenomena. In particular, there's the so-called non-locality. There's the so-called EPR paradox, Einstein-Rosen paradox, which says that in quantum theory there is a link between points which are separated in space, which can't be explained by normal Einsteinian type physics. You seem to violate, Einstein's special relativity theory, and this is called the non-locality problem, and it sometimes go under the term entanglement. That you can have systems which are entangled in some sense, even though they're spatially separated. And a lot of people think this could be important to explaining psychic phenomena, because maybe, Dean Radin, for example, is a great advocate of this. Maybe the fact that different minds or different bodies can be linked in some way reflects the fact that there is this entanglement. Entanglement is a well-established phenomenon on the scale of subatomic particles and even somewhat larger. We don't have any evidence from physics, mainstream physics, that entanglements exist on macroscopic scales, but that at least could be the hypothesis, that in some sense psi exists because we're all entangled, and in some sense the universe is holistic and we're just seeing some aspect of that holistic picture. And also there's the whole link between quantum theory and the collapse of the wave function, which says that consciousness may play a role. The point about quantum theory is we don't know consciousness collapse the wave function, but at least it hints that consciousness may be important. So if you speak to most of the paraphysicists, the most popular approach is perhaps that it's something to do with quantum theory. And indeed, you have people like Harris Walker, who would argue that psi has to be the explanation. That quantum, not only does quantum theory explain psi, then in some sense that psi explains quantum theory. And since then, a lot of people have argued for what are called the observational theories. And the observational theories say that in some sense, not only does consciousness collapse the wave function, but that it can collapse the wave function in a non-random way to produce psychic phenomena. So in some sense, all psychic interactions are reduced to a form of psychokinesis. So that's the quantum approach. Now, as I've said before, I don't think the quantum approach is a proper explanation. It may be relevant to the final theory of psi, but I do not think it provides a full description. Certainly, possibly it might be able to describe some elements of what might call micro-psi, little bits of transmission of information, but it clearly doesn't explain psychic experience, and it doesn't clearly explain ordinary mental experience. So, in my mind, you have to have a deeper theory which underlies both mind and quantum theory. And that deeper theory is what I'm now going on to. This is my fourth picture, and this is to invoke higher dimensions. So I've really described four pictures for you: the transmission signaling picture, the biofield theory, the quantum theory, and now the higher dimensional theory. And the higher dimensional theory, as you know, is the model which I personally favor. But I do want to try and be fair on the other theorists in the field to make it clear that not everybody, even within paraphysics, believes that this higher dimensional approach is the correct one. Nevertheless, it has had a respectable history.
You mentioned earlier the approach of Saul-Paul which I favor. It was published initially in my book, The Roots of Consciousness, and Saul-Paul and I are very close friends. He's been on this channel a number of times. And you also stated, as I recall, that it's the most mathematically sophisticated higher dimensional theory. How does it relate to your own approach?
I said it's most sophisticated in the sense that he was relating his models of hierarchy of consciousnesses to the mathematical symmetry groups, a hierarchy of mathematical symmetry groups. I would say it's somewhat different from my theory, but then my theory is not a final theory. There's quite a lot of, even conceptually, I mean, there's quite a lot of free parameters and the main difference with my theory is the actual nature of the extra dimensions. I know, I haven't met him, but I knew him. I used to meet him about 20 years ago when I lived in California. And let me also say, Jeff, that I read your wonderful 1975 book and volume, and it brought together for the first time, I think, a lot of people, including Saul-Paul. And I was very influenced by that book, so let me thank you for that. I suppose at this point, I ought to describe what my theory actually is.
Good idea.
I like to start off just considering the normal physical world. And the perception of the normal physical world, because if we can't understand that, it goes back to the question of the relationship between phenomenal space and physical space, which you raised before. If we have to understand that before we start talking about extra dimensions. And to me, people have not really fully appreciated the implications of even the standard Einstein picture of four dimensions. Because the point is that you have to think of perception as a four-dimensional process. You know, when people ask, what is the relationship between the object in your mind and the object out there? So they say there's a star out there, and inside my brain there's an image of a star. And in some sense, when people have this debate about the relationship between the star in my brain and the star in the outer space, you get into this whole question about naive realism versus representation theory. To my mind, that is the wrong way of looking at it. That is looking at it from a three-dimensional perspective. If you look at it from a four-dimensional perspective, the picture is very different. You have to look at it in a four-dimensional perspective because that's what Einstein's theory of relativity tells us. So basically, the idea is, you know, in space-time, you've got my brain, which has got a world line. You've got the star, which has got a world line. And there is a light signal that goes from the star to my brain. Now, I can't, of course, draw a diagram in this interview, but you can think of this, a light signal goes at 45 degrees in the space-time diagram. So the perception is not either end of this line, it's this line that goes from the star to the brain, it's the full line. Your perception is the four-dimensional process. And that's a very simple idea looking at a star, but I would say that all our experience of the world is formed from a nexus of signaling world lines which go from the outside world of relativity theory to your brain. And so in this space-time diagram, you can imagine a rather complicated nexus of world lines which connect my brain to the outside world. And part of that nexus, incidentally, are the processes going on inside your head, all the neurons firing and things like that. So now, on this view of things, your experience of the world, of the physical world, is simply space. It's part of space-time. And you might call this an extended mind view. So the star isn't inside your head. The star is out there. I mean, because the perception is a four-dimensional process. And so this idea of perception as a process rather than objects, I think is fundamental. And all this is straightforward relativity theory. But it makes a huge difference, because what it's saying is that actually you can say that your perceptual world is in some sense a map. It is still a map, because when you go from the outside world to what you perceive, it can be modified in all sorts of ways by what goes on in your head. It can be modified by, visual distortions, by higher order cognitive processes. But nevertheless, your mind, in some sense, is identified with the part of space-time which you are experiencing. And so, now the only trouble is, so in some sense, that picture is reconciling the experiential space with physical space. But the only problem is, it doesn't explain consciousness, because as I mentioned before, it doesn't explain the passage of time. Now, because as I said, ordinary Einstein's theory does not explain the passage of time. Past, present, and future coexist. Now, I have my own approach to that problem, and this approach goes back to C.D. Broad. Again, he very influential, and this is to suppose that there actually is an extra time dimension. This extra time dimension is in some sense associated with our mental time. Okay, not physical time. I mean, obviously, when we perceive the world through our brain, mental time and physical time, they coincide. But nevertheless, in principle, your mental time in dreams or in some altered state of consciousness may not be the same as physical time. So one makes a distinction between mental time and physical time. And one regards this mental time as an extra dimension. And so you now have a five-dimensional model. And in this five-dimensional model, you have a four-dimensional slice is the physical world, and another four-dimensional slice is the mental world. But you can see now how this relates to the ideas of John Smithers, and indeed to the earlier ideas of C.D. Broad, that you have that even to describe ordinary perception, you need a five-dimensional space. The extra dimension, so you've got 3 dimensions of space and you've got 2 dimensions of time. Now again, this is not the standard view of a physicist, but it happens to be the picture which I'm pushing. Nor is it the standard view of philosophers, because as you will know, there's a huge literature on the whole problem of the passage of time. Nevertheless, the idea of invoking an extra dimension to explain the passage of time, I think is crucial. And what it means is that with respect to this, if you're an observer in the physical world, you're only looking along light cones in 4-dimensional space. But if you're an observer, a 5-dimensional observer, you might in principle have access to this extra dimension, and then you would be perceiving all of space-time as a sort of as a sheet, if you like, looking at a carpet. You could imagine space-time as a carpet. Normally we're in the carpet, moving along the thread of the carpet. But if in some sense you could get beyond the carpet, above the carpet, you could see all of the space-time, all of that carpet laid out in front of you, past, present, and future. Now, that is talking about normal perception. So what I'm saying is, even talking about normal perception, you've got this idea that you need an extra dimension. And I do believe that. I do think the current picture of physics, that's to say the standard picture of relativity theory, does not explain consciousness, and it does not explain the passage of time. So already you need an extra dimension. But of course, the point about mental experience is that it isn't just confined to our perceptions of the physical world. There are all sorts of other experiences we have which seem to take place in a space. I talked about dream space. You remember H.H. Price was so impressed with dream space that he wanted to make it a separate space. I'm in my own experience of dreams and lucid dreams, I'm very much aware of the fact that dreams take place in a space. And there's no doubt that that space isn't physical space, but nevertheless it is a space. it's experienced as a space and is sometimes indistinguishable from a space.
And you've also reported out-of-body experiences as well that seem to take place in a space that's not quite physical space.
Absolutely, and I talked about that in our first interview. And the point about out-of-body space, it looks like physical space and is sometimes almost indistinguishable, but it's a distorted physical space. And therefore, it's not exactly physical space. You know, you may leave you leave your body, you go through the ceiling, and then you notice that the chimney's got the wrong shape or something like that. It's a distorted space. It's a distorted version of physical space. But of course, the precise relationship between OBE space and physical space is important. And then, of course, people have near-death experiences, and when they have near-death experiences, they seem to go beyond the physical space. They cross the bridge or whatever, they go through the light, and they seem to access a higher dimensional space. And then again, people have mystical experiences, and they also seem to be experiencing a space, but these are now spaces which are different from normal physical space. And I think I referred to before to the problem of ghosts and apparitions. They seem to be in a space, but not normal physical space, in the sense that you can't normally photograph them or feel them. It seems to be a space, but not normal physical space. And so my approach is to say, well, all of these phenomena seem to need a space. So you've got phenomenal space, you've got dream space, you've got OBE space, you've got NDE space, you've got apparition space, you've got mystical space. They all seem to need a space, but it goes beyond ordinary physical space. So my hypothesis is that you actually need a hierarchy of spaces, and you actually need you need a higher dimensional space, which is what I call a universal structure. And this universal structure is the space which is meant to accommodate all mental experience. So it accommodates normal mental experiences with that five-dimensional model. It can incorporate, if you like, paranormal experiences that go beyond the normal physical world, and even mystical experiences, which go, if you like, further beyond the physical world. So the idea is there are a sort of hierarchy of spaces. Now, of course, this idea is not new. I mean, esoteric philosophers have been telling us for quite a long time, within theosophy, for example, that there's a hierarchy of spaces, and so that idea itself isn't new, but I think what is new is trying to relate this hierarchy of spaces, is trying to make it more respectable mathematically. And then, of course, having got this higher dimensional universal structure, which is primarily constructed to explain mental experiences, then the key step is we try and relate that space to the higher dimensional space invoked by physics. Now, so that is the key step when you identify the universal structure, as I've described it, with possibly M-theory space, but not necessarily M-theory. I mean, that's just one theory. It may be some other higher dimensional space that comes out of physics. But the point is that higher dimensions of the universal structure would not be described as respectable. They'd be described as very speculative, and you might not even believe the phenomena they're trying to describe. The dimensions of physics are respectable in the sense that respectable physicists spend their time working on them. So I'm trying to marry up those two spaces. And furthermore, I believe that when you marry up those two spaces using these higher dimensions, that this is going to lead to insights into the nature of quantum theory and the relationship between quantum theory and classical theory. But and so that's my approach. And so it goes beyond the five-dimensional picture. I mean, many people focus on a five-dimensional picture. I mean, for example, I mentioned Jim Bikely. He's keen on a five-dimensional picture. And he has a picture where, because you've got 5 dimensions, you've got links, if you like. You can think of bodies as having an extension in the 5th dimension, and they can communicate because of these links, 5-dimensional links. And that's fine, but I would simply say that's not enough. The 5-dimensional picture, in some sense, is the analog of the of the Abbott flatland picture, because you're invoking one extra dimension. I just think it's more complicated. I think you need more than one dimension to describe the full panoply of phenomena which we're trying to describe. But of course there is more than one dimension in physics as well. So I think of course that makes the theory more complicated, because you've got more than one extra dimension, but it also means you're able to accommodate a wider range of phenomena. But of course, the question in your mind is what is the nature of these extra dimensions? I mean, I referred to how they arise in M-theory or whatever a little bit, but from the point of view of the universal structure, what are these extra dimensions? Well, I've already hinted when I talked about the 5-dimensional model that the extra dimension was time, because you needed an extra time to describe the passage of, the ordinary mental experience. And so, therefore, you might suspect that these other dimensions also have something to do with time. And so now what I'd like to do, Jeff, if we have time, is to have a little digression about consciousness and the nature of time.
We'll take the time. Yes, let's take the time. I'm happy to keep the discussion going until we reach a good conclusion.
Or until the sunlight disappears. Yeah. So, I mean, there are many problems associated with time. One is the problem of the passage of time, which I've already referred to. There's the problem of precognition, which I haven't talked about yet. But I want to talk about another problem, and that is the problem of what I call the specious present. You see, as a conscious being, there is a sort of minimum time scale of what you can be aware, and that time scale is something like 1/10 of a second. And I mean, the concept goes back a long way. It goes back to people like William James, in the 19th century. But the concept is now well understood from a neuroscientific point of view. You cannot experience time which is too short. And I'll give a very simple demonstration. Let's imagine we have a light. I can demonstrate with my finger. Let's imagine there's a light going around. You can see that light going around. I mean, you can just see the tip of my finger, but you can imagine there was a light going around. But I don't know if this works with Zoom, but if I go faster and faster and faster, when the light goes at about 10 times per second, you can no longer see the motion. You just see you see a circle of light. I won't try and demonstrate. I don't think it works with Zoom, but you just see a circle of light. So in some sense, time ceases to exist below 1/10 of a second. So your consciousness comes in discrete time units of something like 1/10 of a second. And we sort of understand that in terms of brain processes. And furthermore, you can't be aware of times which are much too long either. I mean, obviously your brain's only going to exist about 100 years, and you might say there's a longer time scale associated with your short-term memory system, which is much shorter than that, maybe only hours. If my hand goes round so slowly, maybe once an hour, you won't, once every, say, week, you're not going to notice it either. So time only exists within a very small range of times. Something like 1/10 of a second to something like days or years, depending how you measure it. But let me focus in particular on the specious present, which is the shortest possible time. The point about the specious present is that you can't talk about time shorter than that in your experience. Past and present are sort of merged on time shorter than that. But the question is this. Human beings have a specious present of order 1/10 of a second. Who is to say that that's the only possible experience of consciousness in the universe? Who is to say that there isn't a level of consciousness in the universe which operates on a much longer time scale, maybe even on a time scale of 1 million years? If mountains were talking to each other, through seismic earthquakes and things on a time scale of 1 million years, none of us would know, because we wouldn't. Of course, they're not talking to each other, but I'm just saying that we wouldn't be aware of it because the time scale will be so much longer. We wouldn't be aware of that level of consciousness. Likewise, if there was a level of consciousness with a specious presence of a nanosecond, we wouldn't be aware of it. So maybe computers have a specious presence of a nanosecond. That's the time scale on which they process information, but we wouldn't be aware of that. And so who is to say that there can't be levels of consciousness in the universe with vastly different specious presence? To assume that our experience of the universe is the only one there is, that the only consciousness in the universe has a specious presence, to me is very naive. I don't see why there can't be a specious presence associated with individuals. There might be a specious presence associated with a planet. There might be which might be, a year or a day. There might be a specious presence associated with the galaxy, which might be millions of years. There might be even a specious presence associated with the cosmos, which might be billions of years. Now, I'm not saying that there's a consciousness and individual identity on those levels, but I'm just saying we can't exclude it. I'm just saying it's very anthropocentric to say that the only level of consciousness is the one we experience. It's rather like the problem of the electromagnetic spectrum. We know that we observe the universe in a very narrow range of wavelengths, of a huge spectrum which goes all the way from the longest wavelengths of radio waves to the shortest wavelengths of gamma rays. But we only experience the world in a very narrow range of wavelengths, visible light. Likewise, who's to say that consciousness should not exist on different levels? But then the question is, if consciousness exists on different levels, to what extent can we communicate with that? Who is to say that we can't raise our level of consciousness so that the specious present changes? I mean, the point is the specious present does change. Even in normal situations, it changes. The situation, you're in a crisis situation, you're in a car accident, time seems to slow down, your specious present seems to change. On the other hand, sometimes specious present can speed up. I mean, I heard the case of somebody who had a fever and they noticed this light flickering in the window and they couldn't work out what this light was, and eventually they realized it was the sun rising and setting, but their specious present had changed so that the outside world had speeded up. So we know there are processes in which the specious present does change. I mean, it might be a little bit, it might be a large amount, but we know, and the assumption would be that the change in specious present is presumably associated with brain processes.
Under hypnosis, it can change.
And it can change under hypnosis, and it can change under psychedelics, under all sorts of altered states of consciousness. The specious present can change. Now, I would argue that the specious present also changes if you have an out-of-body experience, and that it changes if you have a near-death experience. And I think there's actually evidence for that from the reports. And so my view is that actually to understand consciousness, you first of all have to understand the passage of time, but you also have to appreciate that consciousness requires a specious present. Now, the point is, if our specious present changes, within the specious present, there is no distinction between past and future. And therefore, you can begin to see how a variation of the specious present might be associated with certain psychic phenomena, in particular precognition, retrocognition. And there might also be a specious space in the sense that our awareness can spread in space as well as in time. And so in our normal state of consciousness, our specious presence, it's just like a little circle. It's a specious presence and a spacious presence. So it's a little circle in space and time. That is our awareness. But who's to say that this specious present can't extend, or even the spacious the present? In other words, the region of space can't expand. So I see psychic phenomena in terms of the fact that the specious present, and maybe even the corresponding spacious quantity, can change in some way. Then the question is, how does the specious present relate to these higher dimensions? And What I'm going to say now is very speculative. I mean, everything I say is speculative, but what I'm going to say is even more speculative, Jeff. But in my picture, I told you how the fifth dimension is associated with an extra time. In my dimension, these higher dimensions are associated with different levels of consciousness. And in some sense, these higher dimensions are wrapped up, and they're wrapped up in a way which is associated with the species present. And that sounds, I'm not going to go into that in any more detail, partly because I don't fully understand the concept myself. But it's just, the picture I have is that the hierarchy of extra dimensions, in some sense, are associated with the hierarchy of specious presence, which in some sense is a hierarchy of consciousness. I must repeat, this is not a standard physics view. Most physicists, again, would be appalled, not only that I'm talking about higher dimensions and mental experiences, but in particular I'm talking about higher dimensions being associated with levels of consciousness. But nevertheless, it makes some link with the ideas of Saul-Paul Sirag you mentioned, because he has a hierarchy of consciousness. I have a hierarchy of consciousness. And for me, the link with higher dimensions comes because the hierarchy of consciousness are associated with a hierarchy of time-like dimensions. But it's all very speculative, Jeff. It could be wrong, but but what I do feel is time. There's an intimate link between the nature of time and the nature of these extra dimensions.
As I understand Sirag's work, that there are these Lie algebras and Coxeter diagrams that sort of explain the kind of transformations that take place as you move from different levels in the hierarchy, that it can be mapped out very precisely mathematically.
Well, that's right, but it's quite complicated mathematics. I mean, you've got to understand it within the context of M-theory. The mathematics is very complicated. You know, after 30 years, they haven't solved the equations, and these are some of the biggest brains on the planet, and they still haven't solved the problems. And it might take 100 years. So the mathematics is complicated, and obviously, if one wants a theory of, if one wants a theory of the universal structure, which is going to accommodate these higher dimensions, that's going to be very complicated as well. I mean, in some sense, you can ask the question, if you've got these higher dimensions, and the physical world is just like a slice of the higher dimensions, what is in the higher dimensions? You remember I had this picture of the brain in the bulk. So you've got this higher dimensional space, and you've got to ask the question, if there's a higher dimensional space, what's in it? Well, the only thing I'm aware of is my mental space. So it really doesn't seem so absurd to try and put my mental space into this higher dimensional space in this particular version of M-theory. Now, when you want to ask about what is the nature of the interaction, because I want a precise theory of physics, if you like, between the mental space and the physical space, that's very complicated. I mean, physicists don't yet understand how it works when you're just looking at the physical world. So I can't give you a final theory which is going to say how it relates, how it's describing the interactions on all sorts of other levels as well, things which might not even be described as physical. And I guess that's what Saul-Paul is trying to do. But I mean, it is a very complicated problem. I don't claim to understand it. I don't work on M-theory professionally. It's not I'm a cosmologist. And all I can say is, good luck to Saul-Paul, because, I mean, it's a really important problem. And this theory, it's all very well to have a qualitative idea, as I've described it, but it's only going to be taken seriously when it can be formulated very precisely and it being given a proper mathematical basis. And I don't have a full mathematical basis as yet. In that sense, it's a half-baked theory, and I have to allow for the fact that it may all turn out to be nonsense. I mean, I have this intuition that the higher dimensional theory will turn out to be correct, but that doesn't mean my particular theory is going to turn out to be correct. I mean, the question you want to ask, though, of course, Jeff, is there any conceivable evidence for these higher dimensions? And I think, I know time is pushing on, but the one thing I would like to highlight is the work of someone called Jean-Pierre Jourdan. I don't know if you've ever interviewed him. He's a Frenchman, and he's been studying people who've had near-death experiences. And he's written a wonderful book called Deadline, and which he reports the experiences of people having near-death experiences. And he argues that the best way to explain these experiences is by saying, in some sense, having a near-death experience involves accessing a fifth dimension. So you can see where the link is coming in here. So the idea is that normally, when we perceive the world through the brains, we're in a four-dimensional space. But the idea is there is a fifth dimension. So he's invoking a fifth dimension in much the same way that Abbott invoked a third dimension in Flatland, in much the same way that Jim Butler invokes a fifth dimension. But then his argument was that if you imagine our center of consciousness can move through this fifth dimension, then it would have all sorts of anomalous perceptual features. You could have 360-degree vision. You'll be able to see through round corners. You could see through objects. You would have a very broader view of the physical world if you were moving in this fifth dimension. But not only would space be distorted, he would claim that time would be distorted as well. And what is fascinating when you read the accounts of people, they do report these changes in perception which seem to be consistent with this particular model of motion in the fifth dimension. In some sense, the more you move in this fifth dimension, the more dramatic the perceptual anomalies are. And what's particularly interesting in these states is that he reports that the nature of time changes. So, for example, people don't experience the normal passage of time. They might see the whole of their life instantly. It's like the life review process. And sometimes people say they've transcended time altogether, but I would simply say that they're experiencing a different specious present. So in my way of interpreting those experiences, you're actually going into a state where you have a different specious present, because that, in my model, is related to the fact you're accessing a higher dimension. And so I've highlighted Jordan's book because it is an actual empirical attempt to try and relate the experiences people have, in this case in an NDE, with higher dimensions. Now, of course, my mainstream colleagues, they won't believe in the NDEs, they won't believe in this particular higher dimensional model. But at least within the people who take the phenomena seriously, I think that's important. Because the test of any theory has to be, have you got any evidence? Or are you just making up mathematics because it's fun? And that's really important, because if we had evidence for higher dimensions from physical experiments, that would be great. Because then I could say, oh, well, maybe these higher dimensions really do exist. Maybe they have got something to do with mental space. I mean, even that would be quite a dramatic statement, because you might say, well, if the Large Hadron Collider detected extra dimensions, could that really have anything to do with mental space? I mean, on the face of it, it seems a crazy idea. But nevertheless, you have to think along those lines if you're trying to make this link between physics and psyche. Takes you in strange directions, and you can see why it might seem a rather crazy idea at first sight. But I would say if there is any evidence for higher dimensions at the moment, it comes through psychic phenomena rather than it does through physics experiments.
We do have all of this data, and I know we've talked about near-death experience, out-of-body experience. You've referred to mystical experiences as well, extrasensory perception, psychokinesis, apparitions. We could go on and on. As far as I'm concerned, these are documented empirical findings that require an explanation.
And yes, that's right, Jeff. And let me also just back up a bit and say why this relates to psychic phenomena. Why, for example, how does ESP in clairvoyance, for example, the most basic psychic phenomena, if you like, how does that relate to the higher dimensional model? So maybe I can just explain that. In this picture of a universal structure, the whole point is that your remember we talked about the 5-dimensional model of perception. The idea is that your phenomenal space is not inside your head. So, there are these 7 billion people on the planet. They don't all have little phenomenal spaces in their heads. The phenomenal spaces are all part of a collective phenomenal space. That's when I said that mind, in some sense, extended mind is identified with space-time. I'm actually saying that this mental space is actually a communal mental space. And therefore, your mind and my mind are not actually separated. I mean, they appear to be separated, but they're not actually. At some level, they are all connected as part of this higher dimensional space. So when I talk about this universal structure, it is in some sense a universal mind, and it also contains, and because all the minds are connected within it, that's why there can be telepathy, and because the physical world is also a slice of this universal mind, that's why you can have clairvoyance, because the physical world in some sense is in the mind. And so this approach, in some sense, it makes what is mental space-like. I mean, it makes what is mental communal, and it makes what is physical mental. You see, in other words, you see physical and mental space become two sides of the same coin. You can no longer make this distinction between mental space and physical space. Matter takes on some features of mind, and that's why you can have clairvoyance. And mind takes on some features of matter, which is why you can have psychokinesis and things. So that's the view. And then if you've got this view that you've got this communal mind, then you come back to the whole question of consciousness. What is consciousness? Which is still a question we've not really addressed. I'd say consciousness is associated with the specious present. But the whole mystery is why you and me separate identities? Why is this universal mind, if you like, fragmented into these billions of little minds on this planet? Who knows how many billions of minds elsewhere? The way I look at this is as follows. That fragmentation only exists relative to this specious present. Our identities only make sense with respect to the fact that we have a specious present of a tenth of a second or something like that. If you have a specious present which is much longer than that, you're no longer fragmented into an individual identity on this shorter time scale. So you and I, for example, could be part of a bigger consciousness which operates on a longer specious present. And on that level, we are one and the same. And so you can imagine this hierarchy of spaces, in some sense, corresponds to a hierarchy of consciousnesses. And in some sense, maybe the last step in the hierarchy is, if you like, the cosmic level, where you've got the cosmic specious present, which is 10 billion years, which corresponds to the cosmic consciousness. And so I would make a distinction between consciousness with a big C, which is, if you like, the cosmic consciousness, or whatever word you want to use, and the consciousness with a little c, which is our individual consciousness. Our individual consciousness with a little c is locked into our brain, but the consciousness, and we're all distinct at that level, but consciousness with a big C everything is connected. There is only one consciousness at that level. And of course, I'm just talking as a theorist. I can't claim to have experienced all these elevated states of consciousness, but that's the sort of model that I like. And I do think the idea of a hierarchy of consciousnesses operating on a hierarchy of specious presence, corresponding, if you like, to a hierarchy of different identities, high-level identities, I think that does make sense.
Well, Bernard Carr, I really appreciate this conversation. I think you've been thinking more deeply about these issues than just about anybody I know. It helps, amongst other things, to clarify Sirag's theory for me, or to give more meat on the bone, so to speak, because his theory is mostly pure mathematics. So I want to thank you deeply from the bottom of my heart for sharing your insights into these profound profound questions.
Well, thank you, Jeff, for giving me the chance to talk about it. And I do want to stress again, I know I keep stressing this, but I can't be sure these models are correct. And, I wake up sometimes in the middle of the night and think, this is crazy. But on the other hand, sometimes I think this has to be correct, I'm prepared to bet. I think in the second interview, I talked about making bets. I'm prepared to bet that the higher dimensional approach, something called the hyperspatial approach, will turn out to be the resolution of the problem. It may not be my particular hyperspatial model. Maybe that will turn out to be wrong. Maybe all my speculations about the nature of time and the species present will be wrong. But I bet you that the hyperspatial model will turn out to be correct. And you should bear in mind also that I'm not the only one pushing this view. There are quite a lot of other people who are also pushing the hyperspatial approach. You mentioned Saul-Paul, but there are other people as well. And that's the way it should be. We should have different people exploring different sorts of hyperspatial approaches. And who can tell which one will end up being correct? But I just have a dream that one day these theories will be respectable among even my mainstream physics colleagues. But I don't necessarily know which theory it will be.
Well, and even if they prove to be wrong, completely wrong, it's stimulating me and I think all of our viewers to think more precisely and more profoundly about these questions.
Exactly. And I think it's a general, even in physics, I say, one shouldn't be too obsessed with whether the idea is correct. The question is whether it's useful, because the whole history of physics is a history of changing paradigms where, one paradigm works for a while and then doesn't turn out to be the final picture. You're constantly, over a process of centuries, changing the paradigm until you hope you get closer to the truth. And so the question is, even if an idea turns out to be wrong, maybe all ideas turn out to be wrong in the end, or at least only an approximation. Is it useful? And for example, even if M-theory turns out to be wrong, I bet you it will have turned out to be useful in the sense that it will lead to the theory which is more right. And I like to think the same is true of my speculations in hyperspace, but they're much more speculative than the ideas in physics.
Well, Bernard, thank you so much for being with me.
My pleasure. It's been a long interview, so I'm sorry about that.
No need to be sorry. And for those who are watching, thank you for being with us.